All righty, gang. So the next part that we're going to look at as far as differential equations go is something called a slope field. Before we get there, let's try something. Here's what I want you guys to do. Given or solve the particular solution for, and I'll give you the equation here in a second. Given that y of 0 equals 3. All right, so take a little quick timeout. Huh, did not see that one happening. What happened here? There you are. Given that, and the equation I'm going to give you here is dy dx equals 2x minus 1. All right. Set and off you go. Why don't you guys pause the video, solve it. All right, so let's see what you guys had here. So first of all, this is what we worked on last class. Dy dx equals 2x minus 1. So we're going to separate our variables. And we're going to integrate both sides. And we end up with y equals x squared minus x plus c. Okay, so again, that's the general solution. To find the particular solution, we're going to plug 3 in for y and 0 in for x. So 3 equals c. So the particular solution would be y equals x squared minus x plus 3. That's our particular solution. Well, here's what I want us to do. I want us to take that equation here, and we're going to make something called a slope field. Now, slope fields are really nothing more than a whole bunch of points where you're going to be plugging them in for this particular derivative, and you end up with some sort of value. So let me show you what I'm talking about here. And let's see if you guys can actually see what we're looking at here. So first up, let me throw a whole bunch of values on here. Let me finish making my table real quick. And there we are. All right. So if you notice, we got all these dots on our graph. Now, I don't want to necessarily deal with all of them here because that would be kind of crazy. But let's take a look at this first one. It's the point -2 or -1, 2. What a differential equation says is if we take a point, we can plug it into this slope, this rate of change there. And if we were to do that, we'd have 2 times 1 minus 1, and you'd end up with some value 1. So if we were to continue doing that all the way down here, we'd end up with 0, -2. I'm sorry, 0, +2. I don't know why I put -2 there. 0, +2, so 2 times 0 minus 1. That would be -1. And -1 and +2. Should be -3. So let's see what happens here. First of all, the point 1, 2. So 1, 2. If I were to have drawn a slope through this, that means the line segment that would have passed through that value would have had a slope of +1 because it was equal to 1. So dy dx is 1, that means the slope is 1. So if I were to draw just a little line segment, not the whole thing, but the line segment that would have passed through that point would have been 1. The line segment that would have passed through the point 0, 2 would have had -1. So if I were to draw a line segment through that, it'd be -1, like this. If I were to draw a line segment through the point -1, -2, that would have been the slope of -3. And so it gets a little bit steeper. So if we were to keep going through, and this is kind of what I'd like for you guys to do, keep going through. What I want you to do is I want you to put in values for x and y so we can actually start to approximate what this would look like. So our next value, let's plug in -2, 1. Let's see if we can't do that next row. So -1, 1, 0, 1, 1, 1, and 2, 1. If we plug in this next row of points, what would those slopes look like? All right, so hopefully you guys got -5, -3, -1, 1, and 3. So if I were to plug these in there, so first of all, -2, 1, I'd have -5. That's a really straight slope. Then I'm moving over, I got a -3, so that'd be about, oh, I don't know. And again, we're not drawing a bunch of line segments, all these line segments. We're just drawing just real small line segments that would go through them that would have that slope. -1 would be about like this. +1 would be here. And over here, this would be at 3. And if you notice, if I were to keep going through here, and I try these next set of points, 0, oops, -2, 0, -1, 0, 0, 0. If I keep plugging in these points here, we end up getting a row that looks kind of essentially like the same type of thing here. So if I were to plug it in here, -2, 0 in for my differential equation, again, I'd be at -5, -3, -1, 1, and 3. So again, notice this family of segments kind of looks the same. And if I were to keep going here and plugging in all my values now, so -2, -1, that would give me a derivative of -5. -1, -1, give me a -3. 0, -1 would give me -1. And then we have 1, -1, 2, -1. And last but not least, -1, -2. That would give me -3. 0, -2. And 1, -2. So if I were to plug in all these values, I get this funky little shape. And if I were to just do the same thing, not drawing all the line segments, just drawing pieces of them, of what it would look like, a little snapshot through those values. And if I were to keep up this idea here, if you notice, I start to see things start to kind of fall out a little bit. It looks like it kind of looks a little bit like a parabola. See if we can make it a little bit bigger there. If I were to just follow along one of these sets here, they kind of look like they point to each other like a parabola. So what ends up happening is when you graph your derivative kind of like this, you end up getting a family of functions where you can kind of see the whole family of functions start to show up there. So you end up getting what the particular or what the general or particular solution would look like. So if I don't have a point, when I start to draw and connect all these little hash marks of my derivative, I start to get the general solution of my graph. Again, the purple, green, blue, those parabolas, that would be this right here. And if I knew the particular solution, and it was at 0, 3, if I were to keep this going, I'd probably end up with the same kind of parabola coming forward, but I could actually graph that particular solution through that point. So this is kind of what we call a slope field. All we're going to do here today is we're just going to graph a few slope fields. I'm not going to ask that you graph it for all these points, but we're just going to do a little bit with graphing a couple slope fields, and then we're going to just call it a day. So today we're just adding slope fields. So and essentially when you connect all the little tiny slopes for each of these points, you end up getting a graph of all the general solution of a graph. So let's have you guys try one. Say I give you, let's try dy dx equals x plus y. So we have our x's, we have our y's, and you're going to figure out what dy dx is for our differential equation here. And when you do that, you're going to come up with some bunch of slopes. And I want you to graph the little hash marks of those slopes through those points. All right. So once you guys go through, if you don't do every single value, guys, I'm not going to lose sleep over it. All right. I want you to just kind of get a little gist of what it looks like, just vaguely. And go and pause the video, and then we'll talk about it. All righty. So I'm gonna be plugging these values in here to x plus y. So I'm gonna, again, I'll do it here just so we can see kind of what it looks like on the first one. So all this derivative, this simple differential equation says is I'm just adding my values. So add this one, I get 1, 2. So essentially, when I graph my slopes through these points, I'm going to end up doing hash marks that have slopes that are very similar to what I'm putting up here. So -2, -1, 0, 1, 2. And again, what this allows us to do is it allows us to get a little snapshot where we kind of see the value of the various slopes. So -1, 2 right here, I would have a derivative or a slope of 1. So I'm going to draw a small little hash mark that has a slope of 1. Then I have a slope of 2. I can do better than that. Make it a little bit steeper. And then a lot steeper. And then our next one, I have -1, 0, 1, 2, 3. Then I got -2, -1, 0, 1, and 2. And again, you can kind of start to see, if I were to like have every single point out here, you'd start to see how this really becomes even more drastic, and you can start to see how the general solution ends up showing up just kind of in a graphical way. It's kind of a cool little thing. It's really cool when you look at it in terms of like fields, like magnetic fields or heat fields or whatnot. You can start to see how these different fields would show up a little bit in science. But it would look something like this. Now, the way the College Board would grade you on this is they would give you 1 point for getting all the increasing and decreasing lines going the same direction. So they don't have to be exact. They just, if it's increasing, they could go have a positive slope, decreasing, negative slope. So as long as the increasing and decreasing lines are going facing the right direction. And then you get 1 point for having your 0 or undefined slopes being right. So 0 is horizontal. If I did have an undefined line, it would be up and down. We're going to try one more slope field here, and then we're just going to go ahead and call it a day here. Today is just literally being exposed to what a slope field is and then graphing some slope fields. So nothing really horribly awful about it, just can we graph some slope fields. So let's see here. Our next one, let's try this. You guys are going to try, how about 2x over y. So 2x over y. Go ahead and pause the video and see if you guys can actually do this real quick, and then we will come back and take a look at it. All right, so again, just a real quick reminder of what's happening here. I'm taking my x value and I'm plugging it in, so 2 divided by 2 times -1, and I'm dividing it by the y value. So if I do that, I end up with -1. If I plug 0 in there, I get 0. If I plug 1 in there, I get 1. So I'm going to go and graph those real quickly just so we can kind of see it a little bit. So I have a -1, I have 0, and I have a +1. We keep doing it here. So my next one here, I got 2 times -2 divided by 1. So I have a -4, -2. I'd have 0, I'd have 2, and I'd have 4. So now we go ahead and we plug these in here. All right, so plug these ones in here. I end up with -4, so that's a real tight one there. And then we have a little bit back there. And then we have 0. And then we have a little bit right here. And then even more really, really steep. Now notice all these next ones are divided by 0. Therefore, they are undefined. All these next ones are undefined. Because they're undefined, we're not going to graph them. We just leave them alone. So we're going to leave those ones blank. And then the next one we have here is 2 times -2. Just kind of show you an idea what's going on in this one here. So that ends up being 4, 2, 0, -2, and -4. So if we were to graph these ones, it would be like this. Notice how there's like this weird little symmetry going through it. It's kind of cool. Really steep. 2, 0, -2, and then really steep at -4. And last and certainly least, we plug in these last ones here. So we have 2 times -1 divided by -2. So that's 1, 0, and -1. So on a slope field, all they're asking you to do is just, when you draw the line segments through them that have the given slope, it's just a little bit, you don't go crazy, and you can have this idea of drawing, being able to kind of see what the general solution just would be kind of looking at. And again, you'd have to have a whole lot more points to really, really fully see it, but we kind of get the gist of what this looks like. So again, this would be 2 points would be on the FRQ, and you probably have one of these on the multiple choice as well. So you'd have to be able to recognize what a silt field looks like. So, all right, gang, that takes care of today. I'll see you guys in the morning tomorrow, and we'll talk more about this. Take care.